Hey guys, this is Eddie the Magic Monk doing another trig identity tutorial. In this tutorial, we're going to show you guys how to do a question where you're asked to prove a trig identity. So the only way you can prove this is to use all of the proven identities that you have already seen before and try and prove a new identity using the proven ones. So this will come with a lot of practice, so make sure you don't give up straight away. You won't need anything other than simple algebra and substitution, a bit of rearranging, a bit of actually that's about it. So try and do this question first, and when you're done, come back and have a look at the answer. Okay, so you can see here that in the question we have cotangent squared theta, and in one of the identities we also have cotangent squared theta. So what I'm going to do is I'm going to rearrange this identity to make cotangent squared theta the subject. So then I have cosec square theta minus 1 is equal to cotangent square theta, right? Rearranging it to make cotangent square theta the subject. And now I can substitute this term where cot square theta is in the identity. So let me put that down here. Alright, so now I can substitute this expression where cot square theta is, so it becomes cosec square theta minus 1 over cosec square theta minus 1 plus 1 equals 1 minus 2 sine square theta. Basically, we want to end up with the left hand side the same thing as the right hand side. Okay, so let's keep going. Actually, let's just work on the left hand side for now. So I'm gonna move this over here. Move this over here. Okay, so the left hand side, which is cot square theta minus 1 over cot square theta plus 1, is equal to this. And now what we're going to do is simplify the top. So the minus 1 becomes minus 2, so it becomes cosec square theta minus 2. And the bottom becomes just cosec square theta because the minus 1 and plus 1 cancel down to 0. Okay, so now what we're going to do is separate this into two fractions, and we know to do that because what we're trying to get to has 1 in the answer. And if we separate this into two fractions, then we get cosec square theta over cosec square theta minus 2 over cosec square theta. Alright, so if you have forgotten why you can do that, it's just similar to normal addition with fractions. If you have, for example, 2 over 5 plus 3 over 5, you get 5 over 5. Alright, which is 2 plus 3 over 5. So we've just gone from this back into this, separating a fraction into two fractions. So that's what we did here. We separated this fraction into two fractions, and now the left hand side of this expression, cosec square theta over cosec square theta just equals 1 minus 2 over cosec square theta And you can see here that it is getting pretty close to what we want because we have 1 minus 2 sine squared theta. So what's the relationship between cosec squared theta and sine squared theta? Well, you can see here that cosec theta is equal to 1 over sine theta. Cosec theta is equal to 1 over sine theta. So therefore, what we're going to do is we're going to just work on the side a little bit. So we have sine theta. Oops. We have in the identity cosec theta is equal to 1 over sine theta. So if we square both sides, we get cosec square theta equals 1 over sine square theta. And if we get the reciprocal of both sides, flip both fractions upside down, we have 1 over cosec square theta equals sine square theta. Alright, flipping both sides upside down. So then I can substitute this into here, so I have 1 minus 2 sine square theta, which is exactly the same as the right hand side of the identity that we're asked to prove. Okay, hope you enjoy this tutorial, guys. See you next time.